In this video, I will teach you how you can create your own AI agent in JavaScript using a simple for loop. I have structured this video into 7 points. First of all, we're gonna download or clone a JavaScript Hello World script that simply prints out Hello World, and we're gonna use that script to start our coding from there. Then I'm gonna explain the difference between what is an LLM and what is an AI agent. Then I'm gonna show you a simple for loop that simply counts from 1 to 10. Then from there, we're gonna go to the plan, then execute pattern, which is gonna be the basis for the agentic loop pattern, which is gonna be the next step. Then I'm gonna give you a task, and at the end, we're gonna compare the task solution. Now, please go to this GitHub page. On the GitHub page here, you can see that we have 2 folders, and the starter folder is basically the Hello World application that we're gonna use to create our AI agent from scratch. And code is the folder where the AI agent is already completed. So you can always have a look at the code folder and there you see the entire exercise as completed unit with all the code that you need. So let's have a look at starter to see what we're gonna start with. And here let's have a look at the index.js. And here when we collapse these 2 functions right here, we see the essential parts. We see that this script prints out Hello World, okay? And then the script provides 2 functions here, ask Claude AI and ask OpenAI. And this is basically the boilerplate for calling LLMs. And this is all we need to start creating our AI agents. In your terminal, please type git clone https github.com/jan-salaria/agents-are-loops. Now we have cloned the repository. Now let's step inside. Let's take a look around, and here we can see the 2 folders. So let's step into the starter folder here. And what we're gonna do now is we're gonna install the node packages by typing npm install. And now the node packages are installed. Now we need to open this folder with an IDE. My preference is Visual Studio Code, so I'm gonna type code dot. And now I can see that we have the index.js right here, just like we saw it on GitHub. And I'm gonna collapse these 2 main functions here, and let's have a look at the code. Here we can see that we need an environment file. So here we see an example when we have a look at the left side. So let's create a new file here and call it .env. And I am going to use the OpenAI API. So I'm gonna copy this variable name here into the .env file. And now you need to paste your OpenAI key here. Okay, I'm pasting my key now. And I'm gonna save it. And then I'm gonna go back to the index.js. And now it's time to start the script. you should see this .vs code folder here that contains the debug configuration, okay? So you should simply press F5 and then when it worked, you should see hello world right here, okay? So then the next thing we're gonna test is setting a breakpoint. So right on this line here, I'm gonna click this breakpoint dot here, and then I'm gonna press F5 again. And now we expect the script to stop right here. And we see the line is colored yellow and it has stopped right here. Okay, so I'm gonna click on F5 here, and now we are ready to go. Now let's find out the difference between an LLM and an AI agent. And we can find the answer by first testing the response of an LLM. So let's ask the LLM what the weather will be in Berlin tomorrow. Okay, so let's create a variable response. And now we're gonna call this function ask OpenAI, and we're gonna ask it, how will the weather be in Berlin tomorrow? Question mark. And then we're gonna print out the response. We're gonna say console log response. Okay. And now we need to put this asynchronous code block here in an async function. So we're gonna say async, then curly brackets, and this async function will be executed immediately. So we're gonna put it in this iffy style of defining a function. Okay, so let's test this. Now I'm going to execute the code. And now the answer from OpenAI is, sorry, as an AI, I don't have real-time capabilities to provide current weather updates. You can check reliable weather forecast somewhere else. Okay, so let's try to ask ChatGPT the same question, and don't forget that ChatGPT uses OpenAI LLMs too. Okay, so I'm gonna ask ChatGPT now, how will the weather be tomorrow in Berlin? And now what we see is that ChatGPT searches the weather info online for us. Okay, so what is the difference now here? The difference now is that here we have been talking to an AI agent, whereas here we were talking to an LLM. So what is the difference now? The difference is that an LLM is a static neural network that takes text in and produces text out, whereas an AI agent is a function that takes goal in and produces goal out. And for doing so, it uses an LLM's text out repeatedly in a loop. Many people still confuse the two terms LLM and AI agent with each other. The reality is that they are not the same. An AI agent is not an LLM. An AI agent uses an LLM. Back here in our code, let's comment this out here. And let's create a simple loop that counts from 0 to 10. So I'm going to specify this now. I'm going to say let I equals 0, I is smaller than 10, I plus plus. And let's simply print out I. Let's say I equals and then I. And let's execute this. And now we can see these numbers were printed out. We simply repeat this block of code until this condition here is not met anymore. Okay, so let's have a look at another form of looping. Let's just define a variable letters. And here we're gonna initialize an array, and we're gonna say this has A, B, and C. And let's simply print out each letter. And we're gonna say let L of letters. And here we're gonna say console log L equals, and then we print out L. Okay, so let's execute this. And now we see this loop was iterating through all these letters and printed out A, B, and C. What did we do here? We used some hard-coded lists. For example, this is a hard-coded list ABC. This up here is also a hard-coded list because it implies a list of numbers from 0 to 9. The next step is that we want to create a list that comes from the LLM. Okay, so now we're gonna say const query equals, and then we define a query going to an LLM. So first we're gonna say task, and I'm gonna tell the LLM to create a list of 10 fruits. Then I'm gonna specify the output format. I'm gonna say return the list in JSON format. For example, banana, apple, and orange. Okay, and in order to avoid that the LLM returns some additional explanation or anything, I'm gonna add another rule paragraph here, and I'm gonna explicitly say to just return JSON, nothing else. Okay, so now that we have defined our query, it's time to execute it. So I'm gonna wrap this code block here in an asynchronous function. Curly brackets. Okay, and then I'm gonna run this query. I'm gonna say const response equals await, ask OpenAI, and then I'm gonna pass the query here. Okay, so let's print out the response. And let's execute the code. Okay, and now here we can see that we have received a response here. This is a string that is valid JSON. Now, if you are wondering why this output appears twice, the reason is that here in the ask OpenAI function, we already have this debugging console log that just always prints out the response. And if this is annoying to you, just comment it out. Okay, so let's scroll back down to our latest LLM call here. And now that we know that the response seems to be valid JSON, we can parse it and create an actual JavaScript array. So first thing is we're gonna surround all of our code in a try and catch block, because the JSON parsing sometimes throws an error, and we can catch that error right here. So we can say console log error and then E. And right here, instead of just printing it out, we're gonna create a new variable called fruit list. And we're gonna assign this to be json.parse. And we're gonna pass the string. So json.parse response. And then we're gonna print out that JavaScript array. Okay, so let's test this. So I'm gonna set a breakpoint here and here. And you don't have to do this, but I always do that because I like to go step by step through the code. So now I'm gonna press F5 now. And now we see that we already have the response from OpenAI. And now it's time to parse the string. And now we see the parsing has been successful. And now when we hover over the fruit list variable here, we can see that this is valid, that this is a valid JavaScript array that we can use now. Okay, I'm gonna press F5 another time now. And now that we know that LLM calls can basically result in lists that we can use in JavaScript, we can also let the LLM give us more sophisticated types of lists. And here I want to introduce the plan then execute pattern. And the plan then execute pattern is basically like we let the LLM do the planning for us, and then the JavaScript that calls the LLM will execute the plan. Okay. And our first plan that the LLM should make for us is building a house, or the plan is for building a house. Okay, so I'm gonna define a query now. Let's call it query build house. And here I'm gonna say I want to build a house. Okay, and we want, as a result, we want to have a list of tasks that I can execute later. Okay, so here I'm gonna tell the LLM to create a list of tasks to complete the project. And now to make this a little bit more specific, I want to tell the LLM that each task should be the usage of a tool. And because now there are thousands of tools, screwdriver, wrench, I don't know, bulldozer or whatever, we can now limit the tools a little bit. We can say that we're going to introduce a new section here called tools, and here we can introduce 5 tools that we only want to use. So first we're going to say, okay, we're going to need our hands. Then we're going to need a hammer. We're going to need a saw, a drill, and a screwdriver. Now that we have defined our tools, we can already define the output format, which, just like above, needs to be JSON. And here we can say the list must be in JSON format. The JSON must be valid, and the list also can be empty. And we want to avoid any additional explanations. We're going to say just return JSON, no other text. And then to make this LLM prompt really efficient, we're going to create an example. And here we're going to say this is the array. And inside of the array, each item is an object that consists of 2 key value pairs. And the first one is task. And here we can say gather materials. And material gathering is done with the hands. So here I'm going to say the tool is hands. Then I'm going to specify a second item in this example list. And the second item's task is cut woods. And for this, we're going to use the saw. Okay. So now our query looks okay. I'm gonna copy this upper code right here and gonna comment it out, then paste it down here, and then replace this query with our new plan then execute pattern query. So I'm gonna move this down here. Okay. And now I'm gonna adapt the name. It's called query build house. And it's not the fruit list anymore. It's now the task list. Okay. Okay, so right here, after we have parsed the tasks and the tools, we want to iterate through this list and then create like a story of this. We're gonna say for const task of task list, we're gonna say I am going to, and then we are going to say task.task, and we're gonna say using the tool that we need for this task. So this is now task.tool. Okay, so let's see if this works. I'm gonna set 2 breakpoints here. or no, I'm gonna set 3 breakpoints and I'm gonna run the code. Okay, so now OpenAI is working. I'm gonna have a look at the response. Yeah, this looks like proper JSON. Let's see if the conversion works. It worked, nice. So here we have the list. And now you can see that our story is being written down here. I'm going to gather materials using the hands, attach frames together using the screwdriver, and so on. And this worked. So now the LLM has calculated a list of 1, 2, 3, 4, 5, 6, 7 tasks, and our house is virtually built. In the plan then execute pattern, the LLM is called once to produce a complete plan. And then the code or the agent executes that plan step by step without ever consulting the LLM again. So basically, we have defined our goal, build a house, then we produce a full plan, and then we execute it blindly. And this is actually the problem and the big difference to a real agentic pattern, that the LLM doesn't see the result of each step. In the real agentic loop pattern, the LLM is not only called once at the beginning, but in each iteration. Why? Because on the LLM's response, the next step is being planned. And the next step is either another tool call or the end of the agentic loop, which means that the goal has been achieved or reached. Back in our code, let's comment this out. And let's go to the end of this file here. And let's start to create the agentic loop pattern. And here we also need to call OpenAI, of course. We're going to wrap this in an async function that we're going to call immediately. Okay. Let's start to define the agentic loop. So we're going to use a while construction here. And we stay in this loop until the LLM decides that we can leave the loop. Okay? So this means that we need to define a variable. Let's call it done equals initially false. And while not done, stay in the loop. Now at the beginning of each iteration, we need to let our LLM make the decision of either using another tool or use a tool and exiting the loop because we have built our house. Okay, so we need to introduce a variable called next action, and we're gonna say await ask OpenAI. And here we're gonna say you are an agent trying to achieve the goal of building a house. You have access to these tools: hands, hammer, saw, drill, and screwdriver. Okay. Now we need to instruct the LLM to make a decision. Okay, so now we're going to say respond with JSON only in one of the two formats. If you have a next action, then give us an object where done is first of all false, and you have a tool that we need to use. And here we're gonna use a little placeholder. The LLM is gonna understand that. And then the proper input for that tool. Okay. The second case is if the goal is achieved, then return an object where done is true. Okay? And then on top, give us some result. I don't know, like the house is done or is beautiful or whatever. Final answer or summary. Great. Now at this point, we need to include the information what tasks already have been done. And we need to give this information to the LLM in order to let it decide better when we actually have built our house. Okay, so we're gonna extend this prompt and gonna say history so far. And now we're gonna need a new variable that we're gonna call history. And history is gonna be an array. And in history, we're gonna save these actions here. And then in each LLM call, we're gonna pass the entire array so that the LLM can make the actual decision if we are done building the house. So we're gonna convert this history array into a string that gets bigger and bigger and includes line breaks so that it's going to be an easy to read text. And I'm gonna do this using the map method. So here I'm gonna say called, and then we're gonna refer to the tool here. So this is what we did or what tool we used. So h.action.tool. And here I'm simply gonna use the parentheses because now we're gonna say what the input was for the tool. For example, I gathered wood with my hands. So here I'm gonna say h.action.input. So this would be woods. And now I simply gonna say, or I'm gonna evaluate this, I'm gonna say this was successful. Okay, so that the LLM knows that this has worked out so far. Okay, great. Now that I have converted this array, I'm gonna transform this into a string. And if the array is actually empty, I'm simply gonna print out none yet. Okay, so now the final instruction to the LLM is what is the next action. And now at this point, referring or looking at these instructions here, the LLM knows that it can decide between this or that. And to facilitate its decision, it has the history here. Okay, I think our query now is done. So now it's time to parse the result of that OpenAI query here. So I'm gonna say action equals JSON.parse. Next action. So this response here coming back from OpenAI. And now please have in mind that we can either receive this JSON object or that one. So here I'm going to clarify the first case if the LLM decides that we are done. So I'm going to say action.done. Yeah. Then we're going to set the outer variable done here to true. And we're gonna print out some success message. We're gonna say done. And then because we have specified some result here, we're gonna print out that result. We're gonna say $action.result. And we're gonna break the loop. Okay, so that at this point we step out of the loop, which makes this code here in line 172 unreachable. And in this unreachable code, we can now extend the history, because in this, so this code is unreachable if the LLM has decided that we are done. But if it has decided that we are not done, we reach this code, of course. So sorry for the confusion. So at this point, we're gonna extend the history array. We're gonna say history is history plus the new action. Okay. And then we're gonna print out what the next action actually was. Now it's time to test our code. So I'm gonna scroll up. I'm gonna set some breakpoints here. I'm gonna set another breakpoint here. And yeah, now I'm gonna run the code. Okay. Okay, so let's have a look at the next action. So this looks like a valid JSON object here. And the LLM says that I'm gonna use my hands to draw a plan for the house. Nice, very smart. Okay, I can remove this breakpoint. So let's have a look at the next action. And here it says, use the saw to cut wood according to the plan. Nice. And what is the next action? Assemble cut wood elements together with the hammer. Okay, great. So I'm gonna look at the history object now. What do we have? So here in the history object, we already have two actions, and those two actions are constantly taken into consideration into the LLM decision process. Okay, so I'm gonna remove these breakpoints, and now I'm gonna set a breakpoint here in the end case when the LLM decides that we are done. Okay, so now it has decided that we are done, and I'm going to remove this breakpoint, and the result is that the house has been successfully built. Welcome to the task. So please create a JavaScript class called agent that encapsulates the agent loop functionality and ensure that, first of all, the tools are defined as callback functions and passed into the constructor, and that these function references can be executed. And then also make sure that you pass the maximum number of iterations in the constructor, so as a restraint, so that, for example, you let the AI agent only run 10 loops max. And let's have a look at an example instantiation here. So let's assume that this is your agent class. Then we're gonna ideally create an instance here in form of an agent object and then we pass the function references here. So here we're going to set up a new object called tools, and inside this tools object we have a key value pair set, and each key is the name of the tool, and then the value is the function body of this tool. So for example, this is called hands, and the function body is or indicates that it simply returns the AI agent used hands to whatever the hands have been used for, and then this is done. Okay, so a function's name should indicate the tool's purpose that it represents. So for example, the hands, so the function's name indicates that the agent uses the hands. Okay, and the same goes for other function names, for example, hammer, saw, drill, and screwdriver, and so on. So then you have created an instance of your agent, and then you're gonna let it work. So here, please implement a function called agent.run. And in the run function as a parameter, it would be nice if you passed the query that the agent is going to work on, and then the queries or the agent's work result should be saved in some sort of a variable, for example here the state. And then at the end would be nice if the result of that state will be printed out. Have fun. Welcome to the solution. So first of all, let's create a new file, and let's name it agent.js. And inside this file, the first thing we're gonna do is we're gonna create a class called agent, and this class is gonna have a constructor, and here we're gonna pass an object that has one property called tools, and by default the agent doesn't have any tools, so the instantiator of this class needs to define the tools. And the second property here is max iterations, so the maximum number of iterations that the agent is gonna work. And here I'm gonna suggest that by default, if the user doesn't specify any max iterations, we're gonna say 10. Okay, so now I'm gonna set up the properties of this class. I'm gonna say this tools equals tools, and this max iterations equals max iterations. Now we need to think a little bit. So here in index.js, in our agent first example, or our boilerplate here, we used the ask OpenAI function. So we're gonna use that here again in the agent. So I would suggest that we scroll up to the ask OpenAI function here, and that we're gonna make it exportable. So I'm gonna write export async function and so on. So now I can import this function from our agent class, and I can say import ask OpenAI from, to make it a little bit more clear, from index.js. Now it is time to create the run function that will contain the agent loop. So I'm gonna declare it now as async run, and the parameter is called goal. Okay, and in our previous first example of our first AI agent, we had these variables done, that is false until the LLM decides that the goal has been achieved. Then it becomes true, then done becomes true. And then we had the variable history. And now in our agent class, I want to abstract those variables into a state object, so that each iteration the agent is gonna or the LLM is gonna have a look at the entire state object. So I'm gonna define it as state equals, and then the goal that comes from the parameter list, then the history of the previous tool executions, which is going to be an array, then the done variable that is initially false, of course, and then when the agent is done, we're also going to store the result in this state object. Now that we have defined our state object, we can define the actual agent loop. And here I'm defining it by initializing it with an iterator I that is initially set to 0. I is smaller than max iterations, and I plus plus. And then we're gonna print out the current iteration here. I'm gonna say iteration, and then the index, and then a new line. Now we can define the prompt, and the prompt is more or less the same as the prompt that we have defined in our index.js. So we're gonna say you are an agent trying to achieve a goal, and you have access to these tools. And now we want to use this object here, in which the user has passed the tools as function references, and we want to print out the function names here. So here we can use the function object.keys that prints out the names of keys. So here we're going to say this.tools. And since we're going to get an array, we're going to join that array by a comma separated list. Now we're going to tell the LLM to simply respond with JSON only in one of the two formats. And now we want to respond in the same way, or make the LLM respond in the same way that it has responded here in our example code. So I'm going to copy those two lines now here and paste them right here. So if the LLM decides that we need another action, it will respond in this object here. So done is false. Then the tool that it wants to call next, or that it wants us to call next, and then the input for that tool. Okay. And if the LLM decides that we are done, it returns this object here, and then done equals true, and then some nice final result. Now it is time to remind the LLM of our agent's goal. So now we're going to say goal equals state.goal. And of course, we should also, or we can also refer to goal directly, because this is the parameter here passed to the run function. Okay, so next we're going to define the history of the tool calling. So we're going to say history so far, and then we access the history array, and then for each item we're gonna print a nice text. So each item represents a tool calling. Here we're gonna say called age.action.tool, and here what input did this tool get, and here we're gonna say age.action.input. Okay, and yeah, we're gonna wrap this in a string. And now, in order to make this code a little bit more realistic, you should know that each tool calling has a result, and the results value will be observed. So for example, if I have used the screwdriver on a screw and this failed for some reason, yeah, then I'm gonna write failed here. Yeah, of course we're not gonna write this here, but in realistic use cases, when you really deal with AI agents, for example, if you use a tool that searches your file system for a certain string pattern, maybe it hasn't found anything, and then this operation failed, this tool calling failed. So here, to make this code a little bit more realistic, I'm gonna add age.observation. Okay, and then I'm gonna join all these lines of code here, and if the array is empty, I'm simply gonna return none yet. Okay, now I'm gonna complete the prompt by asking the LLM what is the next action. And now, right after the LLM, of course, I need to send this prompt to, for example, OpenAI. So I'm going to say const response equals await ask OpenAI. And here I'm going to pass the prompt, and then I'm going to parse the result. And now the question is, are we done? So we're gonna check if the LLM has decided that action.done is true, and if it's done, we can update the state and say state.done equals true. Oops. And we say state.result equals action.result. And then we can break out of this loop. Okay, so in this part of the code, the LLM has decided, or when we arrive in this part of the code, the LLM has decided that we need to use a tool, and in this task, using a tool means calling a function. So basically what we have is we have these tools that were passed to our agent class during the instantiation phase, and here we're gonna also as an example, we're gonna take one of those functions by their name, for example, hands. Okay, and now we have this function, and now we can call it. So we can call a function named hands that is part of our tools object as a member of our class. So we can call this function here as an example, and we can, for example, also pass a parameter gather wood. So this would be a valid expression. But since we don't know if hands is always the function that the LLM suggests us to call, we need to refer to the tool name. And my suggestion would be that we're gonna create a function called execute tool. So we're gonna create this function down here, and here we're gonna pass a parameter called action. And now we refer to one of our tools that were passed to our class when the user instantiated it. So here we're going to say const tool equals this dot tools and action is the parameter that is passed from this part of code here. So here we're gonna refer to the action object, and the action object is like this here. So and here we are referring to tool, okay? And here we're gonna take this tool, which is basically the tool name, for example, hands. All right. Then let's do some error handling here. So if for some reason there is no tool, then we need to return a string, and we're gonna say error unknown tool. So if this tool was not passed during the instantiation phase of our class, we're gonna throw that error here. And here we're gonna say, okay, this tool that the LLM decides is a tool that we don't know. In this part of the code, we now know that this function name that the LLM has suggested exists in our tools object. So now we can try and call it. We can say const result equals await and then tool, and then we're gonna, as a parameter, pass action dot input. Okay, so don't forget that action dot input comes from the LLM. Yeah, action dot input. So now we're gonna print out a nice text, and we're gonna say tool and then action dot tool called with action dot input, and then we're gonna print out the result that comes from the action. And here let's just do some basic error handling here. And here we say error equals error.message. And here we are actually done with executing this tool. And we return the result. Okay, now we have defined the function to call the tools. So let's call them. And here we're gonna store the result in an observation. So we're gonna say const observation equals await execute tool. And we're gonna pass the action object here, since right here, when we have passed it, we're gonna find out the function reference in our agents tools, and then the function will be called using the action.input. Okay. And now when the tool has been called, all we need to do now is we need to update the state. And in case you have forgotten, the state is this abstraction up here that consists of the goal, history done, and the result. And now we're gonna say state equals, and then we're gonna update the history fields. We're gonna say history, and here we are going to append a new item to the history that is an object that consists of the action and the observation. Now let's go back to our index.js and let's comment out this previous example here, and let's go to the end of the file and let's import the agent class from agent. Okay. And let's, in the same fashion, the same manner, create an async code block here that we're going to execute at the end. And here I'm going to instantiate the agent, and I'm going to say equals new agent. Here I'm going to pass our tools. And first of all, we're going to define the hands function. And of course, we need an input parameter. And we're going to say used hands to, and then refer to the input. Done. And now I'm going to copy this line 4 times. And here I'm going to use another name. Here this is going to be the hammer. Used hammer to whatever. Done. Or maybe let's use some more sophisticated English. Let's say hammered. Okay. And then we use the saw. And here we sawed. It's done. Then we use the drill. Drilled. And then we used the screwdriver. And then we screwed. Okay. Now let's run our instantiated agent. Let's say const state equals await agent dot run, and let's define a query. And now the goal is that we let our agent build a house using only these resources: wood, steel, concrete, and glass, and only these tools: hands, hammer, saw, drill, and screwdriver. Okay. And then at the end, we're gonna print out the result, final result. Okay. And here I'm gonna print out state.result. Okay. So now the only thing we need to do is testing it. And so let's run it. And did you mean to import agent? Okay, we forgot n.js right here. So let's test it again. And also, yeah, we forgot to export the agent class from the agent.js file. So that's add this export default agent. So let's try to run it again. Okay, now we see the agent is working. Great. That's great. Okay, another error at the end. State.result. Okay, so we need to return something here. Of course, yeah, we need to return the state. Yeah, we forgot this, or I forgot that. Yeah, and now I'm going to run it again. Perfect. Now the house has been constructed successfully with the available resources and tools.